Good morning. Today, I hope you have a calculator. We're going to do a ton of calculating, and we got a lot of pencil writing. So make sure you have a calculator when you're doing your work today. Kind of try to write small. A couple times we don't really have enough room on our paper, so we're going to have to kind of modify a little bit. If you used my guided notes there, but I'll tell you kind of where those parts are. If you'll do these problems really quick, the warm-up says normal. Pause your video and then come on back and let's see how you did. All right. We call it a perfect square when we have a binomial times itself. The square of a binomial. So that'd be something like what we're going to do today is something like if I had an x plus 3 squared, that would be a binomial, square of a binomial. Okay, and we call that a perfect square trinomial. Okay, so I really like the decimals. I don't really like leaving it at 64/9. So since we're working with it, I would really like for you to get it down to 7.1. And number 3, you got to 11. On number 4 today, I don't mind if you stop saying zeros are -3 as long as you say this and they say solve up here, and it's a quadratic equation. But at least put x equals -3 because that says it touches the x-axis at -3. Okay, so zeros are, you can kind of still continue writing it if you want, just so that, again, I was trying to get you to have your frame of mind that we're really finding the zeros on the x-axis, so where this parabola crosses. So now that we're hopefully making that distinction here, we can start leaving our answers as x equals -3 and x equals 9. Both of those quadratic equations only have 1 0. Again, remember, we can have either 2, 1, or no zeros. Today our goal is to find out landscaping bricks. If I want a certain area to be covered, what's the dimensions I can have on my bricks that would make a patio and still use up all my bricks, okay? I don't use this strategy very often when I'm solving quadratic equations, but it's something that they want us to cover. It is kind of a lot of work, a lot of pencil work and calculating, but it's good to know and see if you can follow the process here. So we usually solve by factoring. And so we notice that if I have a perfect square and it's something like x minus 3 equals 0, and it was a perfect square. So again, that would be something like this. X squared, I'd have a minus 6x plus 9. We would square it and we say, hey, that's a perfect square. 3 and 2, or 3 times 1 is 3, and if I squared it, I would get a minus 6. And so then we would do this. We'd say x minus 3 equals 0, and we would add 3 to both sides, and we would say x equals 3. My 0 is 3. Okay, so that's perfect squares make our life a little bit easier. Okay, so if we can make it into a perfect square, well, then we're going to try to. And so what we're going to do is we're going to a lot of times leave a gap here. And you're going to say, well, find what would make this a perfect square. And so here's how we do it. We take the b term, we divide it by 2, and then we square it. Now, I really like to say 3 squared here equals 9 because this 3 here we're going to use as our perfect square. And you'll see, we call that completing the square. We're finding the third term and making it a perfect square. Okay? I know, that's a lot to take in a little bit of time. So here's an example of what we want to try to do. We want to leave a space here. And we want to fill that number with what would make this quadratic a perfect square. So what they did is they took this 6, divided it by 2, that's 3, and then we squared it to get 9. So we're going to add 9. But the real big important part is we made it a perfect square as an x plus 3 times an x plus 3. So again, this part here that they don't show you is I like to do this. That's 3 squared. and then say that equals 9, because that 3 is going to be the number that I automatically put in my brackets to make it a perfect square. Okay? With a little bit of practice, I hope this will make sense. So here is quadratic, the beginning of a quadratic equation, and I want to try practicing making it into a perfect square. So again, we take the b term, we divide it by 2 and square it. Okay, so 10 divided by 2 is 5, and then I want to square it. So this number here has to be at 25 in order to make it a perfect square. Now if I ask me to factor that, that would be this now, because I want that 5 to go right there. Okay, so that's why I like to keep that number there instead of just doing all mental math. Right now they just want us to make it a perfect square. So what they want is they want a minus 9 divided by 2 and square it. Well, negative 9 divided by 2 is a negative 4.5, and let's square it. And I'm getting, interestingly, I don't remember that, yeah, a 20. Now, it's a negative times a negative is a positive. So if you're getting a negative 20.25, something's wrong. Okay, so you're not putting parentheses around your calculator or something like that. I noticed on my calculator it said that, and that's not true. I know it's a positive. Okay, so I didn't put it in my calculator correctly. All right, very important. Think about the signs that you should have. So that number right there needs to be a 20.25. Okay. All right, you try these three here. One's kind of not trying to trick you, but just kind of making sure you pay attention to something. See if you can pick it up. Pause your video and do these two real quick. Three, I guess there's three. Okay, let's see how you did. Did you get fooled on number 1C? Yeah, this one wasn't in order. So this is really my B, the 8. But let's go back to A. I got 36 would complete the square. On number 1B, I got 6.25. And now, if you go back and fix it, if you made the boo-boo, you should have used the 8, and 8 divided by 2 is 4, and 4 squared is 16. Okay? All right. Now, kind of buckle up, because here's our 6 steps all summarized into one little box here. If we're going to try solving quadratics by completing the square, we want to write the equation in the form of x squared plus bx, and you see how the c is on the left-hand side? Right side. We want to put the c on the right. A and the b, we want to be on the left. We're going to leave a space when we write it, and you'll see it here in a second, because we're going to find what number will make it a perfect square. And then we're going to add that to both sides. Would you underline that, please? Because that's important. We got to keep whatever we do to one side, we have to do to the other one. And so now, after that, we'll have a perfect trinomial. Then we're going to take the square of both sides. And then we're going to write our two equations using positive and negative square roots, and we're going to solve it. A ton of steps. So buckle up. We'll see how far we can get on this. All right. So here we go. When I write this problem, I encourage you to write it with some space in between. Put the 15 over here, because we're going to, again, make this a perfect square. We're going to put a number in here. So let's go over and make it a perfect square. Let's take 14, and I do this on the side. I encourage you to do it as well. 14 divided by 2 is 7 squared, which equals 49. So to make this a perfect square, we're going to add 49 in here. Now, what I do to one side, I have to do to the other one. So I'm just going to put that plus 49. Now, here's what's important. This number over here that we said was a 7, well, I don't have to do much thinking about what two numbers is going to factor into. I know it's going to be a x plus 7 squared. I made it into a perfect square. 7 times 7 is 49, and my two 7x's would add up to 14x's if I did FOIL. And let's go over here and do the 49 plus 15. That's 64. So now, to get rid of it, which we did a couple problems like this yesterday, we're going to take the square root of both sides. And whenever I take the square root of both sides, remember I have a plus minus 6 or minus 8 because the square root of 64 is 8. Over here, very important that you just show that those cancel out. So we have x plus 7. My square canceled out my square root. So now we write the equation twice, just like we did yesterday. X plus 7 equals a positive 8, and x plus 7 equals negative 8. Let's go ahead and finish solving it. So my two roots are a 1 and a negative 15. Okay, a lot of busy work. Think back to the beginning of the year when we were having trouble just isolating a variable, doing the steps, and now look at us. All right, so I want to put this 2 because I want to see over on the other side. So now I got x squared minus 2x. Leave some room so we can make it a perfect square, and 2. Let's find out what term we have to add to both sides. We're going to take our b, which is a minus 2. We're going to divide it by 2 and square it. Okay, negative 1 times negative 1 is a positive 1. So that number is going to go up here, plus 1. But what I do to one side, I have to do to the other one. Now again, this is sometimes tricky. I want to take that minus 1, and I want to put it into my perfect square. So my perfect square is going to be x minus 1 squared equals 3. So again, in case you forgot, if I did x minus 1 times x minus 1 and I did FOIL, I get x squared minus 1x minus another 1x plus 1. And now I have x squared minus 2x plus 1. Isn't that my quadratic that I started with? I don't want to do all that. So I want to start using strategy in my patterns here. Okay. So now let's get rid of that square sign. The way we do that is by taking the square root of both sides. Cancels out here. So now I have an x plus 1. Now watch how I do this. X minus 1, sorry. Watch what I do here. X minus 1 equals a plus minus square root 3. Because 3 is not a perfect square. I mean, it's going to be a decimal. Okay, so copy that down real quick, and then I'll show you how I break this up. Okay, so I want to rewrite it twice. I want to say x minus 1 equals a plus square root of 3, and then x minus 1 equals a minus square root of 3. Okay, I want to leave it as a radical. Now let's solve for x. I want to add 1 to both sides. Now this is where it gets kind of weird. X equals 1 plus the square root of 3. I want to add 1 to both sides of here. So that's going to say 1 equals 1 minus the square root of 3. Okay. I don't want to take the square root of 3 and make that decimal yet. Now sometimes math teachers or math problems will say, hey, you can just leave it that way. I like getting decimals because that really doesn't help me on things. But sometimes you might see answers left that way, which I guess that's okay. Now, let's go to the calculator. I need to go turn my light on so I can see my numbers. My light went off. But I'll be right back. But let's finish this off and get it into a decimal form. All right, got some light now. So on the first one, I'm going to put into my calculator 1 plus square root of 3, and mine gives me a square root plus 3 plus 1. I don't want that. I want a decimal, so I'm going to just hit that little double arrow button and make it back into a decimal. And so my first 0, according to my calculator, is a 2.732. And again, we're going to round to the hundreds places. Okay, so that's that one. Now it's kind of weird because now on this one, you're going to say 1 minus the square root of 3. And again, convert it to a decimal, and I get a negative 0.73 if I round it to the hundredths place. So just beware that sometimes they'll leave answers with a radical sign, and then sometimes they'll say, nope, let's go all the way to the end and let's finish it and get the decimal. Okay? All right, man. All right, give these two a try. It's going to take a little bit of time. Look at your examples up above. Again, make sure when you kind of rewrite this problem that you leave a space for making your perfect square. Okay, that we can put a number in here to make it a perfect square. All right, pause your video and try those two, and let's see how we can do. On this 2B, I don't give much room on that paper, so you might kind of just transfer these two to the back, of your study guided notes and write yourself a note that you did them on the back. So that's what I want to tell my kids to do, is just go to the back page, the blank part, and write these two math problems, because you're going to need some room. Okay? All right. Let's see how you did. Here's what I got. I got a -1 and a -9 for my first one. And then over there, you see how 16 on the previous one was a perfect square, so I didn't leave any radical. But 21 is not a nice number. It's going to be a decimal. So again, sometimes you'll see answers left this way. 4 plus the square root of 21, and then 4 minus the square root of 21. So if on a test or a quiz you went all the way to the decimals, and then they say, oh snap, look, here's the answers you get to choose from, well, just look at your work and go back up one step and see if you have a matching answer there. Okay? All right. Look at all that work there. Like I said, it's a lot of work. All right. Here we go now on this one. Now, again, we kind of sometimes get into this habit of forgetting our very first step of factoring. When I have a quadratic equation I'm trying to solve it, I always want to ask myself, is there anything I can factor out first? And a lot of times when I forget, I'll see, oh my gosh, there's a negative. Fisher said, if we have a negative on a quadratic equation, we want to try to make that positive to make our life a lot easier on factoring. So as I look across that problem, I think I can see that I can pull out a -2. So let's pull out that -2. And then what's left? I got an x squared plus, minus 6x, I believe. And then plus 10. Okay. So I don't want to say equals 0. Now, I could factor this guy, and truly, that's what I would do. But I think it's going to be a decimal. So let's try completing the square like we did. So let's get that 10 to the other side. So now I got x squared minus 6x, leave some room to make it a perfect square, equals minus 10. Let's go find our term that's going to make it a perfect square. So I want to add 9 to both sides. So now, really, for the perfect square, this is going to be an x minus 3 squared. It's a perfect square binomial. And then this side's going to be a -1. Now, next step is to take the square root of both sides. And right here, you should notice and recognize, hey, we can't take the square root of a -1. So we can stop right here at this and say there's no solutions or no zeros. All right. So that one's no zeros there. I gotta fix something on my notes here, so bear with me. All right, let's go over and try this one. Can't factor anything out, so I'm just gonna rewrite it here. Now, I'm not gonna freak out about that -8 over there just yet, because watch what happens here. If I take 6 divided by 2 and square it, I get 3 squared, which equals 9. So to make it a perfect square, I'm going to add 9 to both sides. Well, that makes it that I have a positive 1 over there. And I know this is going to be an x plus 3 squared. Again, if I took x plus 3 times x plus 3, I'd get that whole quadratic amount right up there. All right, so now let's go ahead and solve it by taking the square roots of both sides. Square root of 1 is 1. Let's write the equation twice. X plus 3 equals a positive 1. X plus 3 equals a negative 1. Let's continue solving. So there's my 2. All right. I think I gave enough room if you write small on these 2 triads, but you got to kind of write tiny and kind of keep your work organized. So pause your video and give these guys a try, and let's see how we do. All right, let's see how we did. All right, I got a decimal. And so again, sometimes they'll leave maybe the answer this way. Okay, so I get it to that point when I see a square root and I'm doing my square root of both sides and I get this weird decimal one. I'll leave it there and write it twice, once with the plus square root of 3 and once with a minus square root of 3. And then I can convert it to a decimal, so I have both answers. All right. Over here we had square root of 16, so that was a nice perfect square, 4. So I just continue with my work. All right. Again, don't be afraid of decimals. We're going to get more and more decimals now. All right, so here we go. This one makes me a little nervous because you guys keep skipping these word problems, and this is a real basic rectangle. And they said there's a rectangle patio, and I again encourage you to always draw pictures. It's a rectangle patio, and they have enough bricks to cover 144 square feet. I know that's an area answer, so I'm probably going to be working with this area problem, length times width, because they said it's 144 square feet. So that's got to go where the 144 needs to go where the A is. I haven't even read it anymore, but I'm just kind of planning ahead. She wants the length of the patio, so we have a length and a width, to be 10 feet greater than the width. So they're telling us information about this one. So how can I make this say, this guy, the length, is 10 feet more than the width? We've done this a number of times, so I'm hoping that you're saying, hey, if I take the width plus 10, that would be 10 more than the width. Okay? Now when we do area, it's length times the width. So I want to put the W here. It doesn't matter if I put it W times W plus 10 or W plus 10 times W. Let's go ahead and do it. Now I want to scoot this over here. W squared plus 10W. And I want to leave a space because I want to make it a perfect square, 144. Okay, because I want to factor this by making it a perfect square. So I need this number here to make it a perfect square. So I want to take my B, divide it by 2, and square it. So I want to add 25 to both sides. Now I know this trinomial now is going to be this perfect square here called x plus 5 squared. That's why I like that number to be there. I don't have to think about what the number is going to be. Now we need 144 plus 25 equals 169. Let's get rid of my square. Square root of 169 is a plus minus 13. So now I'm going to write the two problems. X plus 5 equals 13. X plus 5 equals a negative 13. Continue solving. Okay, now we got to have common sense stuff. We're doing a patio. It says x equals negative 18 or w equals negative 18. I guess all these should be W, sorry. We can't have a negative 18 measurement, so we throw that guy out right away. He's not a reasonable answer. Now, I did say W. All these letters should be W, sorry. But my W is 8. So that's 8 for that side. And so now if I put an 8 down here, this guy has to be an 18. And they said, well, what's my dimensions? So the dimensions of the patio are 18 feet. Dimensions, you need to use the word by 8 feet. There we go. So we solved it. All right. So do the next one. You saw me flash through that. I did my answers on the wrong one. So do this one. It's exactly like the other one, except for just different numbers. So use it as modeling, but think the process through. Okay. So pause your video, do these. I'm pretty sure we get 1/10 of a foot. So I want to round my answer to the 1/10 of a foot. All right. So here's what I got dimensions of, and here's all my work. That is a ton of work. I got a 24.8 feet by 16.4 feet. Now, if you look at my work over here, here's where my square roots were. I need a square root of 416, which was a decimal. So I said, okay, I'm just going to leave it as that. And I had a -4 plus the square root of 416 and a -4 minus the square root of 416. I hope I did 416 and not 410 over there. Oh, well, it doesn't matter anyhow because you can't have a negative. Okay. All right. So with that, you have practice here today. Here's this Brambley coming in here. All right. So you only have a few problems today, like 8, 10 of them. So do those. Don't skip these review problems on the other side here. They're not hard if you kind of look for them. Which points the solution to this linear inequality? I'm hoping that you remember the solution is the shaded area, so just kind of look at it. And then here's a graph. They're saying, well, which equation would make that? It's already in standard form, so you might think about that. So again, we got to get ready for the test that's coming up. All right? All right. Have a good day, and again, I hope to see you tomorrow.